So we have been sequencing SARS-CoV-2 samples from the very beginning of the pandemic, and some of the techniques have changed over time. But the most commonly used techniques is basically the Arctic protocol, and now we have gradually moved on to our COVID-seq protocol of Illumina, which I believe is based upon the Arctic protocol also. For sequencing on the Illumina platform, we usually use an iSeq 100 or a NextSeq 2000. However, when we had reagent shortages or other issues, we have also used the Oxford Nanopore technology to sequence some of our samples.
So we have used the well-standardized and the popular Arctic multiplex PCR sequencing protocol. And we have used this for both the Illumina and Nanopore platforms. The main reason was that these are the well-standardized and widely accepted protocols used world over, so we just use the same ones.
During the pandemic, we had experience with different methods, such as Thunder sequences, Nanopore technology, Ion Torrent, and Illumina. But Illumina is the methodology that we are using the most here in Brazil now, in our lab and in the Fiocruz Genomic Network. And we tested these different platforms, in special because in the beginning of pandemic, we developed an in-house protocol to sequence the whole genome sequence of SARS-CoV-2. And we wanted in that time to standardize our protocol in these different technologies, because as a reference lab here in Americas, we could share the experience with other labs that had different technologies and also share our protocol. So we standardized it in the Nanopore methodology, in the Ion Torrent methodology, and for Sanger sequence also, because some labs didn't have NGS platform to use the protocol that we were using for NGS. So this was the main reason that we established in these different platforms, but the Illumina platform was the main platform that we are using now.
Well, we have used two different sequencing methods. We've used we started with metagenomics at the beginning because at the time, that's what we had. We did the first genome sequence in Africa, and we used metagenomic to do that. And then after that, we were using the Arctics, targeted genome amplification. So those are the two. But we also use two different platforms for our SARS-CoV-2 genome sequencing. We use the Illumina platform. We also use Oxford Nanopore technology platform on the mini-ion and then the grid-ion technologies. So those are the platforms that we use. For Illumina, we use the iSeq 100, the MySeq, the NextSeq 2000, and the NovaSeq 6000. So those are the different platforms that we used.
Hello. We are at Cayetano Heredia University in Lima, Peru. And this is where my laboratory is based and where we have been doing all the COVID sequencing since 2020. Let's have a look. Hi, I'm Pablo Sukayama, and I'm an assistant professor of microbiology at Cayetano Heredia University, and we are today in my laboratory on campus. So we are a small academic group that was working mostly on bacterial genomics prior to the pandemic, working on how to track antimicrobial resistance genes between clinical and community environments in Peru. But we have been slowly increasing our capacity for NGS and bioinformatics since my return to Peru. And so around March 10, 2020, we had to close down the lab because of COVID. This was a few days before the national emergency and lockdown was declared. And we stayed in lockdown for a few weeks until April 2020, when, thanks to a grant from the National Council of Science and Technology, they were able to fund the first set of sequencing runs for SARS-CoV-2 using the Arctic primers, the Arctic protocols on our Illumina platform. So this took a couple months, but eventually we started generating around 200 genomes per month on one instrument. Again, very small scale, all manual extractions, but slowly we were able to scale up our capacity by collaborating with other laboratories at universities outside Peru. So we were slowly decentralizing sequencing capacity, and we work with folks in the Arequipa region to the south of Peru, and also in the Amazonas region to the north of Peru, that were working already on sequencing, and they started generating sequencing data. We trained them here initially, then after a few months, we were able to visit their laboratories, and together, this small academic consortium ended up generating approximately 3,000 genomes, or about 10% of all the genome sequences from Peru. Slowly, the National Institutes of Health, our national public health laboratories, have stepped up their capacity, and now Peru is routinely sequencing around 1,200 genomes per month from 25 regions. So we're doing now weekly monitoring, and of course our capacity has increased greatly, yet we are still way below what other countries do. So we're generating around 1,000 genomes per month. But this has enabled to track local variants, and in 2021 we were able to identify a novel variant that eventually was named the Lambda variant and emerged in Peru and expanded to 30 countries around the world, and it was first identified here. As mentioned earlier, my lab does mostly bacterial genomics, so we had to rely on local collaborators to find the best place to get our samples processed. So this is a neighboring lab at Cayetano, the Emerging Diseases Laboratory. Luckily, these folks had already been working with Zika, chikungunya, and other emerging viruses in past years, so they had some facilities already enabled that were suitable for SARS-CoV-2 work. So we had to do some repurposing of the labs to do the processing here, and this is the setup that we came up with. We had to build this anteroom. We had UV lights for disinfection, and then this preliminary room where all the changing and washing and autoclaving happens. And then we also set up a negative pressure system just to be extra sure. And we proceeded in enabling this laboratory. And this is where we do all the RNA extractions. In the beginning, it was all manual extractions on column-based kits. And so daily, we were able to extract approximately 48 to 96 samples. And in recent months, we have moved to automated systems, which enables 48 samples at a time. It's still very low throughput, and we are reaching the maximum capacity of what we can extract here with available staff and machines. But this has been working for us throughout the pandemic, and so far we have processed and sequenced approximately 3,000 samples in this small laboratory.